And thank you for being here. I really am honored to be able to present at the Geospatial World Forum. It's the first time for me here, so I've enjoyed the presentation so far. I wanted to tell you a little bit about Thomson Reuters. I'm sure most people here have probably heard of Reuters News. When you hear Reuters, that's what most people think of as the news service. However, that's less than 5% of our revenue. So I wanted to talk a bit about what Thomson Reuters is. And then, as Prashant said, I'm going to give a couple of different examples of how we're using geospatial data to power our customers' decision-making process. So first, Thomson Corporation and Reuters came together in 2008. Thomson Corporation acquired the Reuters group at that time. But both of these businesses have a very long legacy, and I thought I would talk a bit about that. On the Thomson Corporation side, the oldest asset they had in their portfolio was Sweet & Maxwell, founded in 1799. So quite a legacy there. And then on the Reuters side, Paul Julius Reuter started Reuters Limited in 1851 when he was trying to sell news information and trading information between Paris and London. So kind of a legacy as well there. And then in 1934, Roy Thomson, who's the founder of the Thomson Corporation, acquired his first newspaper in Canada. So, Prashant, there's a few Canadian ties in my presentation I think you'll like. And then in the 70s, the Thomson Corporation started acquiring other assets and building assets to sell to professionals around the world. And when I talk about professionals, I'm really speaking of a pretty broad array of professionals. That ranges from commodities traders that use some of our financial and risk products, to scientists that use our IP and scientific scholarly research. It could be accountants, CFOs, government agencies. It really spans a pretty broad spectrum of professionals across the world. And as a company, we're in 100 different countries with 57,000 employees. And just one of the products that I'm going to talk about here briefly is Icon. It's one of our financial desktop products. It's on over 400,000 desktops in different trading and brokerages throughout the world. And Thomson Reuters touches 1 billion people a day with news and insights. That's an incredible number when you think about it. 1 billion per day. I know that we just heard Google Maps is used by 1 billion people per day. That's a phenomenal number. So the first example I wanted to give is from a financial markets perspective. We have a product that we call Icon. And Icon has done some really unique things recently with one of our releases that really married geospatial data with, and this is kind of a big data and open data example. We married some private data sources that we had with public data sources to provide a very compelling position for commodities traders. So the first thing I'm going to show you, this is a map that's provided by Microsoft. We partnered with Microsoft, so this is a Bing map. Sorry, Michael, to that. So in this picture, what I want to zoom in on is an example, and I used a Canadian example since I know Prashant was going to facilitate the session. And there, if you see on that map, there is Voisey Bay that's highlighted in a green dot there in Canada. And this map is basically taking the geographical data, but then marrying a couple of different interesting data sources. So the first thing it's marrying here, as you see on the left, you have an opportunity, if you're a commodities trader using this product, you could select what commodities, so energy, metals, agriculture, and then you could also use some of the data that Michael talked about around shipping information, so you could look at what types of vessels do you want to track in the world. You could look at ports and see if there are congested ports. You could look at weather and overlay weather data on this picture. So what I'm going to focus on is just kind of a quick scenario of how a commodities trader might use this information and really benefit from this geospatial data. So let's say that you're a commodities trader and you're trying to track nickel. Voisey Bay is one of the larger producers of nickel in the world. So this shows some metadata about Voisey Bay. It's currently green, which means it's in operation and things seem to be going well. But if I zoom in a bit on Voisey Bay, you'll be able to see a couple of other data examples that get overlaid on this map. First, the smelter that processes most of the nickel is in Sudbury. So we see here that Sudbury is online. So if you're interested to see if there's going to be potential disruption in the nickel processing by a very large producer, and you're a commodities trader, you can see that data at your fingertips here. But then let's say if you wanted to focus in on a particular cargo ship. This is the Umakai vessel in this particular example, and you can see that it's green, which means operations are going well. It shows its current heading where it is based on some of the data Michael described in the previous example. It's constantly pinging through GPS and giving its signal of where it is and its location and direction. So you could also use that to track that ship to see where it's been. And we use this is a small example. We also have scenarios where we show, much as Michael's example showed, what the traditional path had been for particular types of commodities. And if there's some type of disruption, say a hurricane in the area or something of that nature that could disrupt shipping vessels, then that could have an obvious impact on the supply of a particular commodity. And if, as a trader, you'd want to know that information because, information is power, and make trades kind of in advance of that information. So in this case, we can see the history of that particular freighter. But if we wanted, we could filter it by all different types of cargo vessels, and as you see, you can see where any of these are located in that exact harbor or bay, and get more data about any particular one that you wanted. So pretty powerful from the perspective of being able to take public data about shipping information, take private data about that we provide relative to commodities, what the current price is, what positions are out there in the market today. But then you can marry that with weather data. In this particular example, we've overlaid kind of the ocean and sea temperature, which this last winter was very important because the weather was a very harsh winter, so the ice packs were heavier, so that would affect potential cargo lanes that might be moving to process that nickel and ship it around the world. So that's one example, I think a very powerful example of how we're using this data in the financials market, which many of you may not have known about. A second example that I'll use, also from ICON, is around agriculture. I'm going to use Illinois, this is a state in the United States, and this example is going to talk about crop production and the use of Landsat imagery and other data sources to predict what's going to happen to crops. So in this case, you see a typical statistical bell curve of what normally happens in a growing season and harvest season. And I'm going to overlay 2009, which as you see, it's got a nice bell curve. It started a little late from a rain perspective and vegetation perspective, as you see, but the crop finished very strong, and it was a good year for this particular crop. In 2012, we had a very brutal kind of dry and hot summer. You can see in this example where it started off with a normal curve, but then fell off precipitously. Now, looking at graphs like this is not really that interesting. I mean, you can see data points and generally see what's happening. But when you marry that with geospatial data, it's more powerful. So if you look at the bottom of the screen, you can see on the left-hand side you have 2009. On the right-hand side you have 2012. And I'm going to play through kind of a time progression so you can see what's happened to the vegetation on the ground there. And you'll see under 2000, each date, there's what day of the year it is. So it's going to work through the harvest season. Basically, that bell graph I just showed you, however, now in a graphical geospatial way. So as you can see, started off good in 2012, but then started to decline. And you can see a marked difference in the color and the vegetation. That translated into that crop doing very poorly that year. So if this was corn and you're a commodities trader on corn, you can start to see and trend what's happening to the vegetation to predict what's going to happen to the supply of that particular state's crop in that particular area. So very interesting information. So now I'm going to switch gears a little bit. What may surprise you is that Thomson Reuters does the most work with geospatial data in our tax and accounting business. I just showed you market data. But in the tax accounting space, it's not really a coincidence. At first, it may not be intuitive, but in order to tax something, you have to know its location and what it is. So it's very important, whether it's a sales and use tax or a VAT tax, and you need to understand what jurisdiction you're paying tax in and where that product or service is from. It's very important, but it's also important in areas of land, particularly as in most countries. In the local government, more than 90% of its revenue comes from local property taxes. And they use that to build roads, educate their children, just general good for the population. The problem is in many developing economies where they don't have documented or mapped jurisdictions or boundaries for land, that is, it becomes very, very difficult for those countries to govern those assets as well as raise the revenue they need to do the things for their population. So I want to talk about a project that we've had with Thomson Reuters here, implementing our Aumentum project in Uganda. This product is a land registry as well as a cadastry mapping system. And if you look at Uganda, they have more than 90% of their property does not have boundaries and it's not registered appropriately. So they have a real difficulty here. And if you look on the upper right-hand corner, you can see that 85% of the population depend on land for their livelihood and income. When you add that to what's happening from a population perspective, you can see how not having clear land registry and ownership rights is going to start to come to a head, because you're going to have a very fast-growing population that's heavily reliant on the land, and then this debate about who owns the land is going to become, and the asset itself is going to become quite contentious. Through our project, though, we've implemented Aumentum, and we've taken 500,000 titles and digitized those into a database, which has been very helpful for them. We took 16,500 spatial maps, entered them into a national land registry system that they can now use. We've taken their archives and also put them in a database. So now they have a national database for the archives if they need to look up land ownership rights, if there's a court case or dispute, things of that nature around the land. So you can see very manual process in the past that would have been very difficult to deal with. And at a national level, we've now automated that. So if you're in a local government, and now you need to do some type of customer service to something dealing with the land, you now have the ability from a local government office to look into our database. You can now view on a electronic map what's happening. You can zoom in and get metadata about that particular property and parcel. And as well as we've increased the customer service. So you see here, in the past, customer service, it would take, for 1 month, they would process about 400 transactions. And in the current scenario, using Aumentum software, they're doing 5,000 a month. So it's improved their not only their accuracy and their ability to govern these parcels of land and assets, but it's also greatly improved the lives of the citizens there and their ability to get information about those assets. So what I hope you walk away from, if you're asking a question, what should I remember about this presentation? I think the first thing is Thomson Reuters does a lot more than news. We're really about providing professionals and governments with information and assets. And pretty much all walks of life, Thomson Reuters is somehow involved. And if you think about the reach of Thomson Reuters, given the population today, we're reaching 1 in 7 people in the world on a daily basis. So imagine the opportunities for geospatial data and the continued opportunities we have there to serve the people, to basically better define our place and better explore our country and our world. So thank you very much.